We've now seen one-dimensional cases where a boat travels in a river and the direction of the river current is either parallel or anti-parallel to the direction of the boat. Now we have a boat which wants to cross the river onto the other side, so from A to B, perpendicular to the flow of the river. And let's begin by taking the easiest case, that there is no current in the river. The boatman will steer the boat towards B, so straight across. This is the intended direction of travel. So the boatman wants to get to B, steers the boat towards B, and finally does get to B. And this concept occurs naturally to us. But now let's take a case where there is a river current and see what would happen. Now we have a current in the river pointing towards the right. The boatman is steering the boat from A to B, and that is his intended direction. So the boat is being steered from point A to point B, and you can see that from the orientation of the boat, it is parallel to the line AB. But due to the presence of the current, the boat actually reaches point C on the other side of the bank. This x direction displacement of the boat, BC, is known as the drift and is caused by the current. This is a case of two-dimensional motion or motion in a plane. So you try to steer the boat from A to B, but you end up at C due to the river current. Let's say now that the current is stronger than this. What do you think would happen? If the current is stronger, the boat, which is actually being steered from A to B, starts drifting towards C, and the drift BC increases when the current is stronger. The boatman is steering the boat from A to B, since that is his intended direction of travel, and the intended direction can be seen from the boat's orientation, which is parallel to line AB. But the boat actually drifts down to C due to the current. In this case, there is no current, and the boat is being steered from A to B, where B is not exactly opposite A. So in this scenario, the boatman deliberately steers the boat along the line joining A and B, and the boat moves along that line. So this is the intended direction, and there is no current which would have caused it to deviate from its course. But we do have a drift, not because of the current, but due to the angle at which the boat heads out. dB is the drift in this case. So the drift is the deviation from the bang opposite end and not from the intended destination. Now let's see the same with the current. The boat is being steered from A to B, but drifts along to point C due to the current. Watch closely the orientation of the boat. It is parallel to the line AB, the intended direction, but the boat ends up moving along line AC. So here too there is a drift DC, which is the x displacement of the boat. This drift is caused due to the intended direction and the current in this case. The orientation of the boat tells us the intended direction, as it would be parallel to the intended direction. But the actual direction in which the boat moves is the direction as seen by a stationary observer on the ground. Here, the intended direction is AB, so the boatman was trying to get to B, but the actual direction is AC, so as seen by an observer on the ground. In this lesson, we touch upon boat motion, which is not parallel or anti-parallel to the direction of the current in a river. When there is a current in the river, a stationary person on the ground observes the motion in a direction that is different from the intended direction of the boat.